Let R be the region bounded by x equals 5, y equals 2x plus 9, and y equals minus 4x plus 21. To find the volume of the solid R, well, when R is revolved around the x-axis, what's the integral? And so there it is. How did we come up with that? Well, the deal is I've graphed it. I went to the graphing tools, and so I put in the this function and this function. And so the one on the top here, or so the or yeah, let me get this straight. So this is the G is 2x plus 9. And the other one is the blue minus 4x plus 21. All right. And one thing that can be helpful is to first go to here's where I went to regular Desmos. Regular Desmos, just the two-dimensional grapher, put in the two functions and the x equals 5, put in all three things. Got a nice look at the flat. So this is the region R they're talking about, region R. And we can see it goes from here, which is at 2, to 5. The region R does, right? So this is the region R that we're going to rotate then about the x-axis. We're going to rotate it over. Let me make that a little bigger. We're going to rotate this region over the x-axis. Okay, notice it stops right there, so there's going to be a little hole when we rotate that over the x-axis. So anyway, getting back to it. So then we know this must be hitting it 2, and this is it's hard to tell on this thing. That's why I do the flat graph first. All right. So then we say okay, and then you do the rotation. We can see what we're going to get is this. We take this region R here and we rotate it about the x-axis. We're going to get this big like frisbee shape. And we want to know, but it has thickness to it. Frisbee with some thickness. It's like a stadium. Maybe that's it. Maybe it's a stadium. Whatever. I want to find the volume. How do we find the volume of it? Well, it's uh it's got an outer radius and an inner radius. So, right, because there's we're going to use these are all discs. Technically, they're washers. We're going to use washers. So the volume of a washer is pi big R squared minus pi little r squared. All right, let me draw a picture, make sure that's clear. Okay, so that's a washer. If you want to find the volume of that washer, you've got the little radius, and then of course you have the big radius. And if you want to know, it's like a donut or a tire, you want to know the volume, which is the space in between the circles. That's a washer's volume, the volume of the washer. Well, then you've got to take the whole circle and you've got to subtract the whole. Let's just say the whole in the middle. You got to take out the hole in the middle, right? You got to find the area of the whole thing, that's pi big R squared, and subtract out the pi little r squared from the middle. So that's the volume of a washer. So that's what we're dealing with here. These are washers. And so as we look at them over here in the diagram, bring this up right here. So we're going to have here is the little radius. So let me draw that a little better. Let's do it right here. There's the little radius r, and then right next to it, and all the way up. is the, if I didn't lose the little one, there's the little radius R, and then there's the big radius, capital R, right? That goes all the way up. That's what's going to create the washers as it's rotating around. So, so therefore, what is big R? Big R goes all the way up to the red circle. So it's G, right? And little r only goes up to F. It's up there at F, right? There's little r. Whereas big R goes all the way up to G. All right, so there it is. So little r is F. So that order matters. So you got to get that order right. So we're going to say, say it's pi big R. What is big R? Well, we say it right here. Big R is the G minus pi. And what's the little r? The little r is F. And we're going to integrate that from where to where? Well, we're going from 2 to 5, right? From 2 to 5. We know that's 2. We learned all that from this graph. 2 to 5. That's where the region is, from x equals 2 to x equals 5 dx, because dx is the thickness, right, of each of these little uh, disks. They have a thickness dx. So the volume of a washer, yeah, I should have said it's that times dx, because dx is the thickness. So, right, because this right here is the washer top, right? Whole circle, take away the hole in the middle, times the thickness, which is dx. So there's our integral. Now we got to put in so g is 2x plus 9. So this will become the integral from 2 to 5. I'm going to put the pi in the front. 2x, what was it? 2x plus 9 squared minus, and then what is f? F is minus 4x plus 21. And then the whole thing is, well, I forgot to square this square. There we go. I put the pi in the front, so there's g squared, there's f squared. There's what we type in. So there we go. So make sure you're really, by the way, learning these integrals from the graph. I know you can say, well, I just memorized it. It's that one square myself. Well, there's going to be so many of these on the exam and all mixed up, and they don't all do the same thing. So make sure, and the order matters. If you switch that, that's everything. And the order all comes from the picture. Being clear which one's the outer radius, the G, which one's the inner radius, the F. All comes from the picture, being clear on the picture. And so there we go.